Today's lesson is dividing polynomials. This is the second part of our dividing unit. So let's take a look at what this looks like. So we are going to simplify this, and these happen to already be in factored form, so it makes it a little bit easier for us. So the first three examples are going to be in factored form, and the last three examples we're going to have to do a little bit of factoring in order to simplify. So I'm going to look at this and I'm going to reduce what I can. So I look at 14 and 42 and ask myself, well, is there some number that goes into both of them? And so remember, you can use the GCD command on your calculator for that, and it will give you the greatest common denominator or the greatest common factor between 14 and 42. If you do that, you'll find out that it is 14. 14 actually goes into both of them. So I cross off 14 and 42, and I divide both of them by 14. So 14 divided by 14 is 1, and 42 divided by 14 is 3. So I end up with 1 and 3. Then I look at the other things that are factored, and I say, is there anything that's the same on the top and the bottom? And I notice that there's a 2x plus 3 on the top and the bottom. So because they're the same on top and bottom, I can cancel them out. Because if you remember, anything divided by itself is just 1. And so they reduce and give me 1. Now, x minus 1 and x plus 1 are not the same thing. And so I can't cancel those. I can't cancel any part of those. So I have canceled everything that's the same on top and bottom. Now I circle what I have left. So I have a 1 and a 3 left. I have an x minus 1 on top and an x plus 1 on the bottom. And the last step is just to rewrite what I have left. So I have 1 times the quantity x minus 1 and on top, and on bottom 3 times the quantity x plus 2. Now I've put this little arrow because remember, I like to write things in proper math, and we don't usually put a 1 out in front of something 1 times. We just leave that off. And so the left hand side of that arrow is kind of like slang math, and the right side is kind of like proper math. And that's all there is to a problem like this that's already in factored form. So let's look at example 2. Same kind of problem. So I rewrite it and say, okay, well, what goes into both 18 and 4? Is there something that goes into both of them? Again, you can use that GCD on your calculator. You can use that on Desmos if you have Desmos. And I know that 2 goes into both of them. So I cross off 18 and 4, and I divide them both by 2. Well, 18 divided by 2 is 9, and 4 divided by 2 is 2. And then I look at what I have factored, and I see, oh, there's an x minus 1 on top and an x minus 1 on bottom, so I can cancel those out. And then the last two things that are left, the 3x minus 4 and 4x plus 3 are not the same, so I can't cross those off. So I circle what's left, and there are the things that are left, 9, 2, 3x minus 4, and 4x plus 3. And I now am ready to rewrite it. And I put the things that are on top, and the things that are on bottom. So I get 9 times 3x minus 4, and 2 times 4x plus 3. And now that is all divided out and reduced to lowest terms. Example 3. Again, it's already all factored for you. So we look at what can we reduce. Well, is there some number that goes into both 25 and 15? Well, sure, it's 5. So I cross off 25 and 15. I divide them both by 5. So 25 divided by 5 is 5. And 15 divided by 5 is 3. Now, is there anything else that's the same on the top and the bottom? Well, it looks like there's a 5x minus 3 there and 1 there. And there's also a 2x minus 2 there and there. And so those cancel as well. So I circle what I have left. I have a 5 on top and a 3 on bottom, and that's all I have left. So I rewrite what I have left, and it's just 5 over 3. So 5/3. Now remember, the next three examples are going to be given to you not in factored form, and so we have to add an extra step of factoring. So I look at the top. I'm going to look at the top separately from the bottom and say, well, what is something that both 6x squared and 21x have in common? Well, they both have an x, and so I can pull out an x. And then I look, is there a common factor that goes into both 6 and 21? Well, 3 goes into both of those. So the GCF that I'm going to pull out of the top is 3x. And then I look at the bottom and say, okay, well, does 3x squared and negative 24x have anything in common? Well, they both have an x. And then I look at the 3 and 24 and say, do they have anything in common? And 3 goes into both of those. So I rewrite it using the GCF. It happens to be 3x on top and 3x on bottom. So I factor that out. And when I factor out a 3x, or think about it like we did problems like this last week where it was what do I have to multiply 3x by to get to 6x squared? Well, it's 2x. That's that missing factor. So 3x times 2x is 6x squared. And 3x times negative 7 is negative 21x. So whatever I pull out has to multiply with what's left to give me what I started with. So I pull out the 3x from the bottom, and I'm left with x minus 8. Now I look at, well, what can I reduce? Well, there's a 3x there and a 3x there. And it looks like nothing else is the same on top and bottom, so I circle what's left, and I rewrite what I have left, which is 2x minus 7 over x minus 8. Example 4. Same kind of problem. I'm going to have to factor out something. I'm looking for what do they both have in common. Looks like the top, they both have an x, and it looks like the GCF between 5 and 20 is 5. So I'm going to pull a 5x out of the top, and I look at the bottom, 10x squared and 35x, they both have an x, and the GCF of 10 and 35 is also 5. So I pull out a 5x, and then I put what I have left. So what would I have to multiply 5x by to get to 5x squared? Well, an x. Or I could ask myself, what do I divide 5x squared by? Or when I divide 5x squared by 5x, what do I have left? And that's an x. You can think about it either way. And 20x divided by 5x is 4. Or think about it as 5x times what is 20x. And I do the same thing on the bottom. When I pull a 5x out of 10x squared plus 35x, I'm left with 2x plus 7. So I'm going to reduce anything that I have in common. Well, there's a 5x and there's a 5x. The other two things are not the same. So I'm going to circle those. And then my last step is to rewrite what's left. So when I rewrite it, I get x plus 4 over 2x plus 7. And that's my final answer. And one more of those. 6x squared minus 4x over 8x squared plus 2x. So this is division. I didn't say this at the beginning. This is considered division because remember, a fraction bar is a division sign. So it is 6x squared minus 4x divided by 8x squared plus 2x. So, but we have it written as a fraction rather than using the division sign. Okay, so I look at 6x squared minus 4x and look for the GCF, and they both have an x, and the biggest number that goes into both 6 and 4 is 2, so it looks like a 2x on the bottom. And then let's look at the bottom. They both have x's, and what goes into both 8 and 2? Well, 2. So in both top and bottom, my GCF is 2x. And then I'm left with, when I pull out a 2x, I'm left with 3x minus 2 on top. And when I pull it out on the bottom, I'm left with 4x plus 1. Because remember, I'm looking for what do I have to multiply 2x by to get to 6x squared minus 4x. So I'm going to reduce. Well, they both have a 2x, top and bottom. And so I cross those off. The other two things do not cancel, so I circle those. And then I rewrite what I have left, which is 3x minus 2 over 4x plus 1, and I'm finished with that problem. So again, remember the first three examples, it was already in factored form. I just cancel whatever I can. And then in the last three examples, you had to factor something out first. So it is your turn to try this. There is an assignment on Alex that has problems just like both types of these examples. I think there are 5 of each. So, log in, get that finished. Thank you to all of you who have been going in and doing your work. Please know that you can still go back and finish any work that you haven't. I have set all the assignments to have a late date of June 11th. Everything has to be in by noon on June 11th to be counted for credit. So please make sure that you are scoring at least a 6, because you need a 60% to get credit. If you score less than 6 on an assignment, so you score 5 or 3 or 1 or whatever, you're not going to get credit for that assignment because you didn't get to 60%. So you can go back and try these as many times as you want. You only have to fix the ones that you missed. You don't have to worry about the ones that you already had right. So please make sure you're doing that. And as always, please make sure that you're staying safe. And I hope that you are all staying healthy as well. Please feel free to email me if you have questions. I usually get back to you pretty quickly. Also, you can join me on Tuesday mornings or Thursday afternoons for office hours. Those are posted on Google Classroom. You just go to the Irish office hours, open up the calendar and select the date, and then you can join the Google Hangout that I have set up for that day for office hours. So, I can help you there, or I can help you just by email. And I'm more than happy to help you anytime. So again, stay safe, stay healthy, and we will talk to you next week.